Hi everyone, my name is Yifan Liu, a PhD student in public policy from Georgia Institute of Technology. Today I want to present our research findings about citizen-generated intelligence for transport electrification policies. The research project was conducted by Yifan Liu, Cade Lawson, Catharina Hollauer, and our advisor, Professor Omar Asensio. We focused on EV public charging stations and get insights from big data generated from consumers during their transaction of EV charging. So the first thing is, why do we care about EV charging infrastructure? Climate change is here. Transportation sector is a major contributor to carbon emissions. For example, 27 of total US greenhouse gas emissions came from transportation in 2020. And EV has therefore become an important strategy for decarbonizing transport, mitigating climate change, and addressing health and other externalities. We can also see that trend from the booming worldwide EV market. As the graph shows, the sales have doubled year over year in 2021 to 6.6 million. So EV is so important, but why do we focus on charging infrastructure? Studies show that subsidizing the deployment of charging stations could be twice as effective in promoting EV sales compared with directly giving the same amount of money to EV buyers. This is due to the indirect network effects between the deployment of charging infrastructure and the EV sales. However, due to the poor data interoperability and decentralized ownership, we hadn't known much about citizen opinions about the existing EV infrastructure, not to mention how to use them to inform related policy. So in our research, we leverage big data techniques to collect many publicly accessible station reviews covering millions of reviews from many stations across the US, Europe, and East and Southeast Asia during the period from 2010 to 2020. The data was collected from a popular EV charging locator mobile app. For each station, we have some basic information, and we also have this interesting check-in information that the consumer left their review about their charging experience after they charge their car. And for each review, we can use NLP, natural language processing techniques, to classify the topics of discussion and consumer sentiment. For example, like number 2, thanks, very busy dealership, but happy to allow user QCDC. So the AI algorithm could automatically identify the topics of this sentence: functionality, availability, and dealership were mentioned in this sentence. And with this information, we build a data set and explore the effects of technology standards, such as different types of networks, on the charging performance. We identify 3 types of charging station networks, including non-network, closed networks such as Tesla, open networks such as Open Charge Point Protocol, OCPP, which provides an open source communication standard for EV charging stations. And for Y, the dependent variable, we use a percentage of reviews that mentions functionality-related topic as a measure of charging performance. Here are our regression results. The red points on the left side mean less functionality-related discussion, which indicate more reliable services. And the blue points on the right side represent more functionality issues. So we can see the first row, the Tesla network, or on the left side, very significant red points. which means that Tesla supercharger network is more reliable with consumers, generating 12 to 15% less functionality mentioned globally as compared to non-network stations. And OCPP standards significantly underperform the Tesla supercharger network, which is understandable. However, OCPP standard also far worse than non-network charging station, except for European market, which is a bit surprising, because this means that the advantages of the open networks haven't taken into effect. So in conclusion, we can leverage AI power tools and citizen-generated data in mobile app, just like what we did to extract insight to inform policymaking. And the largest closed network Tesla is providing the highest degree of reliability to the best of our knowledge right now. And the station within the OCPP open network doesn't deliver better charging service, which is a bit surprising. And there is some heterogeneity in the quality of charging station by points of interest, which is kind of the secondary conclusion of our research. For example, the charging station at hotel and lodging location perform better than those at other stations. So here is our presentation, and we look forward to hearing your comments and questions, and looking forward to seeing you on the conference. So here we also attach some regression results and measurement for Y to some technical details just for your information. Thank you so much.